Let's look at the special cases that you can encounter when solving systems algebraically. So what I mean by special cases would be the most common scenario is you have two lines that intersect and there is one solution. But it's possible that we have two lines that are parallel. So what point do they have in common? Well, they've got nothing in common. This has no solution. And the third scenario would be that we have one line that coincides with another, meaning they fall directly on top of each other. So how many points do they have in common? Well, there are infinitely many points in common. So what we want to look at in this is how do these two special cases play out algebraically? What do they look like? It's easy to tell in a graph, but how does it work out in the algebra? This example has two equations in standard form, so elimination is my go-to method when that happens. If one of the equations is solved for one of the variables, I use substitution. But I'm going to create a pair of opposites, so I'm going to try to get rid of my y's. So if I multiply this bottom one here by -3, that would create positive 3y, and then I have a pair of opposites. So if I multiply the bottom one by -3, just going to recopy this top one, 6x minus 3y equals 12. The bottom one becomes -6x plus 3y equals -12. You spotting something? I hope so. So we stack and add, and what do I have? Opposites, that's 0. Opposites, that's 0. So 0 on the left equals 0. Okay, so everything's dropped out here, but I do have a true statement. This is true, which means that there are infinitely many solutions. If we were to graph these, we would see that we have the same line, and I'll show you that with the website Desmos very quickly. So here's the website, desmos.com, the graphing calculator, and what I've done is I've entered my two equations. So in red is the first and in blue is the second, but the problem is you can't even see them because they're directly on top of each other. But if I just tap the one equation, it should switch to red, and there you can see tap the blue, red, blue, they fall directly on top of each other, and this confirms that I do have infinitely many solutions. So let's look at this one where I have one equation that is in standard form and my second equation is in slope-intercept form. When my initial data is given like this, I choose to substitute. If they were both in standard form, I would use elimination. So what I'm going to do here is, since my bottom one is already solved for y, I'm going to take that and plug that in place of y into my top equation. So I would write 3x minus 2, I always open up a set of parentheses, is equal to 7, and I put the 3/2 x plus 5, what y is equivalent to, in those parentheses, and now I solve. I'm just distributing my -2, so I recopy the 3x. This would be minus 3x minus 10 equals 7. On the left, I combine like terms, and 3x minus 3x is 0, leaving me with -10 equals 7 and no variables in sight. So the first thing you want to make sure you didn't make an error, that you didn't plug the equation into itself. I didn't. So I have a false statement here. This would be a case where it is no solution, meaning if I look at a graph, I would see that I have parallel lines. So what I've just done to verify this is I've used the website desmos.com that has a really nice graphing calculator. This is not one that can be used on standardized tests, but you do not have to change your equations to slope-intercept form in order to see this. So I can type it in just as they were given. I can see I have two parallel lines, therefore it's no solution, just like I got algebraically. Finally, let's look at an application question. An adult pass for a county fair cost 2 more than a children's pass. So I'm going to use A and C for the cost of each of these things. So an adult pass, I'm going to say A, is equal to 2 more than a child's pass, so C plus 2. When 378 adult and 214 children's passes were sold, the total revenue was $2,384. So in algebra, that's saying 378 times A plus 214 times C is equal to $2,384. So what would your go-to method be? Substitution or elimination, or of course graphing. But since we're talking algebraic, I'm going to go with substitution. And why am I doing that? Well, A is isolated, so I can plug in A into the opposite equation, or take out A and put in C plus 2. So that's going to give me 378, open up a set of parentheses, plus 214C equals 2384. And I am going to write the C plus 2 in its place. So go ahead and distribute and combine like terms, which gives me what you see here. And now I'm going to combine my like terms, which would be 592C plus 756 is equal to 2384. Subtract 756 from each side. Produces 1628 on the right, and then I divide both sides by 592 to get C equals 2.75. So $2.75 for child's pass, but it's asking me what's the cost of an adult's pass. So I'm going to plug this, just need to rewrite this because I can't handle it being sloppy like that. Plug this back in here for C, so an adult pass is $2 more. So it would be $4.75 for an adult pass.